Welcome back again. This is another edition on the Machine Learning Simplified. This time, we want to look at a artificial neural network called ANN, or for short, neural network. It's a machine learning model inspired by the structure and function of biological neurons in the human brain. It consists of interconnected nodes, which we call neurons. In biology, we also have which is organized in layers that process input data to produce output called predictions. All right. So the key concept is the neurons itself, which are called the nodes in machine learning. So these are basic computation units that apply weights, biases, and attention functions. We also have layers. The first is input layers, which receive raw data we call features, and we also have hidden layers. It's an intermediate layer between the input and output, which learn patterns, which can be multiple. We also have output layer, which produces the final output, which is called prediction. This could be classification and it could be regression, as the case may be. So we also have weights or bias, which are the parameters that are adjusted during the training to minimize error. We also have attention function, which I explained above, which introduces the non-linear linearity, which is such as ReLU, sigmoid, softmax, and so on. So that is our attention function. We also have what is called forward propagation, which means the direction of the data. Data flows from input to output layer direction. That direction. We also have backward propagation, which adjusts the weight based on prediction error that is gradient descent. So you can see a simple illustration of machine learning, artificial intelligence here, artificial neural network here. We have our input supply, this S1, S2, S3 to the total number of features here. So which is our S here. We have our weights here, which is multiplying each of them later. Then everything will be summed together here with a function. Then we get the output here. So from here we can see that our function here, our output here, is giving us a feature multiplied by the weight to the total number of feature we have. So our net input is equal to, which is our output, now will be our from I, which is the beginning of the feature, down to the last number of feature. We multiply and sum together. So this is what we get as output. So our final output is calculated in this form. So you can implement this one by using our breast cancer data set, which we have used before, having two data classes, malignant and benign. Okay, so don't forget, we have used this several times, and by now you should know the structure of the data sets by now. So we're going to run our library first, which are required. So we load the library and then we load the data set, which I've loaded several times. So it's 0 for malignant and 1 for benign. Then we process the data. So don't forget that when it comes to neural networks, scaling is very important. Yes, neural network is very sensitive to feature scales, right? Yes, to help to converge easily and speedily. And at the same time, it also generalizes a new random values. When you run it, each time you run it, you have different accuracy, different values of performance changes over time. So there are several reasons for that, but this one is handled by setting a seed here. Can you see? So this we have handled this. So if you don't do this, set the seed like this, you keep having different values of a performance result, different values of accuracy, and so on each time you run it. So it will not be stable, and you want a stable result. So you have to set the seed here. Don't forget we are using 0.2, which means 20% for testing. We should rest 80% for training as usual. So we run run here. Then we now build the model here around this line. So we have don't mind the warning. So we call our keras sequential here. So we pass our question here, which is ReLU. Then our input unit is our data set here. The shape here is passed 1. Then hidden layer. Then we pass our 16 units activation here. Activation ReLU again, which is this hidden layer. Then we pass our final output layer here, which is 1. So this is binary classification actually. So we compile the model using optimizer called IDAM, and the IDAM is usually used for binary cross entropy classification. So our metric is accuracy. Sometimes you can change the metrics based on what you want. If you want to use regression, you can use also MSE, okay, or square root of it as well. So depend on what you want from neural network. And you can do both classification and also regression at the same time, just like SVM. Okay, so we have some parameters we have used which I just explained now. We have hidden layers, ReLU, pass avoid vanishing gradients, segment output, squashing output to 0.1 for binary classification. So the loss function, which is about binary entropy now, measure error for binary classification, which is log loss. The optimized adaptive learning rate for efficient gradient descent. All right, so then we train the model here by using 50 epochs. Okay, you can change the epoch so you can see the running of the program is as it's running here. Can you see? Can you see it's going? So it's running here. So we have a parameter parser which can be changed. We have batch size is 16. Validation speed is 1.1 with 10% of training data for validation now. So our variable is 1. So this can be adjusted as you want. Right, so you can also evaluate the model here in a very simple way. Model evaluation. So we have 97.37 accuracy. You can see the model here. This is our Gaussian matrix here. So you can see how powerful ANN can actually classify for us our data. Now, so from here you can see that 42 correctly predicted Maglinat, which is true positive, true negative rather, and the 69 correctly predicted benign, which is true positive. Then 2 false negatives, which misclassify Maglinat as benign, is what we got here, and we have 2 false negative rather. That we have one false positive, which misclassified benign as malignant. So this is what we have as our classification and interpretation. So we can also visualize the training process if you want by plotting a Matplotlib library. So you can run this line of code again. You see the output here, so you can see how our training process is doing. You can see here, this is our simple epochs. So accuracy here, we have training and validation here, so you can see. So that is just what we have here. So it's very simple. You can also look at the model. If you want to save the model, you can save the model for further use later. So, but for now, we are not dealing with that for now. So we're going to be doing that in the future, how we can save the model and call the model later. So that is just a model. So this is our output. If you run this now, so to plot the model, after you have saved, you can plot the model. So if you run this, it gives you this now. You see, you can see the shape and that push shape now. You can see what you have here. So you can also do that in different ways by using what they call plot model library function, plot model function from Keras unit, so utility. So just call plot model here and pass your model in, and the file name, which is this, you save to this file. So you can open the file later and maybe put in your thesis or manuscript if you want. It's needed. So this left to right orientation. Now this from left to right. So this is another method. We can also use what is called Matplot. Okay, so to do that, so we can also plot. Looking at our what is called weight, our weight distribution. How the weight is well distributed. You can see the weight here. By running this now, you can see the weight here. This is our weight values. How is it distributed? So just in case it's needed for further analysis. So this is what we have in a simple linear network. Linear artificial neural network. So we are going to be looking at more of this later, because this is actually the foundation for deep learning. So what I did just is very simple introduction to neural network. AMS is more complicated, more complex than this, but I just make it simple now for a beginner to follow, to understand what neural network is all about and how we can run it by passing or plugging our values, our data set into it, then see the output, how it works. Then you can now upgrade as we journey gradually. So you can see the process as it goes. This will be explained more later as we continue in this series. Thank you so much for listening. I will see you in the next class. I will look at another areas. Thank you. If you have not yet subscribed, you can subscribe to enjoy more of this training as we go deeper in this particular classes. And if you you can like, you can also comment if anything you want us to add, or that it's not clear, that you need more explanation. You can also put in the comment section. I will see us in the next class. Thank you so much for listening.